Hi everyone, today our team want to talk about one of the topic in calculus, that is applied maximum and minimum problems. This topic is presented by all of us, and I'm going to show you the animation that we make and voices by all three of us. Please enjoy. Hi guys.
Hi Danish.
Guys, I need your help. My mother's birthday is coming up, and I want to get her something special. Any ideas?
How about a beautiful flower garden? It's a thoughtful and unique gift that she will love.
That's a great idea, Hakim, but how do I calculate the maximum and minimum area for the garden? I want it to be just the right size.
Well, Danish, calculating the maximum and minimum area involves concept from calculus. We need to find the critical points and evaluate the function to determine the maximum and minimum values.
Yeah, it sounds a bit complicated, but don't worry, Haziq is good at math. He can help us with the calculations.
Thanks, Hakim. Danish, to calculate the maximum and minimum area, we will need to consider the factors like available spaces, the type of flowers, and the desired shape of the garden. We can use the calculus to optimize the area based on these factors.
That makes sense. I want the garden to be both visually appealing and functional.
Absolutely. We can also consider factors like sunlight, soil quality, and irrigation to ensure the flowers thrive in the garden.
I appreciate your help, guys. With your suggestion and Haziq's expertise in calculus, I'm confident I can create the perfect flower garden for my mother.
You are welcome, Danish. We are here to support you. Just let us know if you need any further assistance.
Hi, I'm Hakim. So, what is maximum and minimum problem? Applied maximum and minimum problems involve finding the highest or lowest value of a function within a given context or situation. This type of problem often arise in real-world scenarios such as our scenarios, where you want to optimize a certain quantity or find the best possible outcome.
So, the problem statement is Danish want to surprise her mother by making a rectangular flower garden with area of 16 meters square. The area is surrounded by a grass border 0.5 wide on two sides and 1.5 as shown in the figure. Let x and y be the length and width of the flower garden respectively. This is the technique to solve the problems. The first step is to find the derivative. The second step is let the derivative equal to 0 and find the values of the variables. The last step is to do second derivative test, which is if second derivative is bigger than a 0, then it is a maximum value, and if the second derivative is less than a 0, it is a minimum value.
The statements we can find first combined area of the garden and the border, the dimension of the garden that will minimize the combined area of the garden and the border, and lastly the minimum combined area of the garden and the border.
From the information given, we already have the flower garden area that is 16. To find the rectangle area, we need to times the length and the width, that is x times y equal to 16. Then we can get y equal to 16 over x. To find the total area, we need to times the whole rectangle area, that is the outside one. So we need to sum up first 1 plus 5 plus 1 plus 5 plus x. So we can get 3 plus x. And for the other one, we need to 0.5 plus 0.5 plus y. Then we will get 1 plus y. Then we will times it. 3 plus x times 1 plus y. We will get 3 plus 3y plus xy. So, to find the area, we need to substitute the y into the total area. So, it will be 3 plus 3 times 16 over x plus x times 16 over x. So, the combined area of the garden and the border is x plus 48 over x plus 19. Next, we can find the dimension of the garden that will minimize the combined area. We already have the area that is x plus 48 over x plus 19. Then we can change it to x plus 48x to the power of negative 1 plus 19. After that, we will differentiate it to 1 minus 48x to the power of negative 2, or 1 minus 48x, 1 minus 48 over x squared. After that, we let the derivative to be 0 and we will compare it. 1 minus 48x squared equals 0. We will bring the 1 to the other side and it will be 48 over x squared equal to 1. From here, we can find x. To find x, we just need to square root 48 and we will get 6.9282 meter. Then we can find value for y. We only need to substitute x into the equation. 16 over 6.9282 and we will get y equal to 2.3094 meter. Lastly, we can find the minimum combined area of the garden and the border. For this, we need to use the second derivative test. So from the first derivative, we already have 1 minus 48x to the power of negative 2. So we need to differentiate it again and we will get 96x to the power of negative 3 or 96 over x to the power of 3. It is greater than 0, so it means it is a minimum value. So from x, that is 6.9282, we can substitute it into the area. So it will be 6.9282 plus 48 over 6.9282 plus 19. And we will get 32.8564 meters squared.
Sum up everything. In conclusion, applied maximum and minimum problems in calculus play a crucial role in optimizing quantities and finding the best possible outcomes in real-world scenarios. By understanding the problem, formulating the objective function, and analyzing critical points, we can determine the maximum or minimum values of a function within a given context. So let us all master Calculus 1 together. Bye!